Well, I'm very flattered by that introduction. Thank you very much, Tom. Hello. Thank you first to Noah, to the whole BookNet Canada team for inviting me back. This is kind of round 2 for me. I spoke here last year, and last year at the Tech Forum, I spoke about linked data, the idea that all metadata can be expressed as a relationship between two entities, a subject, a verb, and an object. Those who heard that talk will be extremely glad to hear I will not be saying anything about that this year. But the point about linked data is that it is a different way of expressing, in most cases, much the same sort of data. So last year, linked data. This year, I want to explore that idea of different representations of the same data further. Why are there different representations? Why are there different metadata formats? We've all heard of Onyx. Many of you will have heard of Mark. There are all sorts of other ways of expressing book metadata. Well, why can't we just have one? Why can't there be a one-size-fits-all sort of metadata format? First, I want to say a little bit about myself and a little bit about the organization I represent. With luck, that works, yes. So, as Tom said, my name's Graham Bell. I'm Chief Data Architect of Editor. Don't please get carried away by that. My other title is Only Data Architect at Editor. It's not like I have a team of sub-architects who work for me. Editor is a very, very small organization. I've worked there for about 4 years. And before that, I was at HarperCollins in the UK for nearly 15 years, I guess. But always working in that intersection of technology and the creative process in publishing. So now I'm at Editor and take on the role of managing editor itself from April. Editor itself is a very small, not-for-profit membership organization. And by very small, I do mean very small. This stage is bigger than our office. And there are normally 3 or 4 people there. It is a tiny organization. Mostly when I ask people how big Editor is, they think there's maybe 10 people work there. But in fact, there's 3 on a good day, 4, and the office is quite crowded. So we're a standards organization, a trade standards organization. We're not about how long is a centimetre. We're about defining standards that help the book trade work. Our fervent aim is to develop technical standards that help you sell books, because that's what we're interested in. Editor brings together a bunch of experts in metadata, identifiers, publishing systems, technology, book selling, and business. The 4 of us who work in the office are supplemented by consultants and by our members. Our members are very important to us, not just because of the revenue that they bring in, they pay us to be members of Editor, but because they bring us their skills. We value them for their skills, their insights, and the questions they pose to us. Their difficulties in running their book business are the fodder that feeds us in terms of developing standards. We're based in London, but we have members all over the world. Many here in Canada, in the US, most countries in Europe, and even in the Asia-Pacific region as well, Japan, Korea, China, Australia, and so on. We serve a truly global audience. As well as building metadata standards for the trade, we also provide management of other people's standards. We run the International ISBN Agency. There's 150 or so ISBN agencies around the world, each one dedicated to a specific country. I believe Libraries and Archives Canada is the ISBN agency here, and Bowker in the US, Nielsen in the UK, but there are 147 others, and we provide a fairly thin cover, a sort of umbrella management organization for them. We do that in a slightly smaller way for 2 other standards, ISNI and ISTC. Quick show of hands, who has heard of either of those? Oh, wow, that's actually more. Who has heard of both of those? Slightly fewer, but the proportion of hands there is more than I expected. Fantastic. So I'm not going to talk about them today. We also work closely with other standards organisations to ensure that our standards meet the needs of their stakeholders too. Standards inch forward through the collaboration of a coalition of the willing. Standards development is very much a social activity. Social seemed to be the buzzword this morning. But developing standards, whilst it may seem dry and technical and academic in some cases, it's actually very social activity, because what you need to do is draw people with you. We're helped because people often look to editor, and our members gain some insights from us that we draw from our other members. That's the secret plan. We borrow your watch to tell somebody else the time. So what I'm going to talk today, luckily, is not that. This, because that's a bit of Onyx, and many in the audience will have seen this sort of thing. It's what editor is, frankly, best known for. Everybody's seen it. Everybody knows that book trade metadata looks pretty much like that. Note the amount of purple and the amount of yellow, I guess. This is a theme that will crop up over the next 30 minutes or so. There's relatively little yellow data compared with the amount of purple markup up there. So that's Onyx. And this is another format that a few of you will immediately recognise. This is actually MARC. This is the data format that's used for bibliographic metadata in the libraries world. A higher, in a way, signal to markup ratio. I wouldn't say signal to noise, but signal to markup ratio. There's much more yellow in proportion. And the markup, the fields, in a way, the tags, are a much smaller proportion of the file. I guess that most people in the room are familiar with one or other of these formats. A few of you will be familiar with both. It's obvious that the two data formats contain the same sort of data. They cover the same domain. They contain the same information in many cases, but there are some significant differences. The data obviously looks very different. MARC is extremely cryptic. Onyx is very verbose, but the difference goes much deeper than that. Onyx is built on an underlying model of the world, a model that gets called index. That's index with a C and an S at the end, standing for interoperability of metadata in e-commerce systems. Index was a late 1990s European Union-funded study of what you might call the intellectual underpinnings of e-commerce. It focused on what we needed to do to make e-commerce work for buying and selling intellectual property across the internet. It built a model of the life cycle of any intellectual property, any content, from conception through to exploitation and the end of the life cycle when eventually the intellectual property rights expire. Here, diagrammatically, is one part of the framework that Index developed. The diagram comes from Godfrey Rust's model of making summary of the outputs of the Index project. As you can see, Index concerns itself largely with abstractions and manifestations over on what for you is the right-hand side of the diagram. And you can see that the first is turned into the second via some event. We have abstraction at the bottom right. We have an event, which is labelled expression here, and then the manifestation at the top right. The event fixes the abstract thing, the intellectual property, into something concrete, which is the manifestation that you can then sell. The abstraction might be a musical melody, the melody that runs inside the composer's head. The expression could be writing it down on a manuscript, or the performance that's solidified in a particular recording that's then fixed on a CD or a digital file, and that's the manifestation, the product that you can sell. Of course, these events happen at a particular time, a particular place, and they involve particular people, those on the left-hand side of the diagram. But most people who work in book trade metadata, this is actually a relatively unfamiliar diagram, unfamiliar territory. But we could make it slightly more familiar by drawing it like this. Index talks about abstractions as being the highest level thing that we care about. Manifestations, those are the products, the things that we sell. And items, individual copies of those products. One individual book, and I realise I've left the book that I was going to hold up at this point in the other room. So imagine I've got a book here, the 2011 release of a particular book, and individual copy of that book is the item at the bottom of that stack. We can change some of this terminology without really changing the meaning of the diagram. Quite often we call these things at the top works, in the middle manifestations and items. Sometimes we call the thing at the top a title. It's a little bit looser, but it means roughly the same thing. The thing in the middle is often called not a manifestation, but a product. And then the item, of course, is the individual copy. Don't forget the relationships between them, the little yellow arrows. A work is manifested in a manifestation. And a manifestation is instantiated in an item. Very rare words, but Index uses those to describe this, in effect, intellectual abstract model of how the world works. The three-layer model here is topped off by a further relationship. Oops. There's the relationship. Works can be related to other works. The original Swedish novel is related to the translated English version of it. They're both separate works, but they're closely related through a relationship that says this one is derived directly from that one. So that derived from relationship is much the same as the instantiates or manifests relationship. And we can see the shadows, the imprints of this particular model of item manifestation work in the way that Onyx itself works. Onyx for Books is concerned almost exclusively with that orange manifestation level. That's the level that the ISBN works at as well. This all seems a bit theoretical, but the rights that publishers acquire from authors, the sub-rights that they sell, those are often right at the top of that stack. What you're buying and selling when you acquire rights or sell sub-rights are works. You then exploit those works in products manifestations. Onyx is built on this underlying model. So what about the library world? Well, the library world ends up using a slightly different model. Actually, it uses several slightly different models, but let's just stick with one for the moment. So this is one of the models that the library world uses. Some of you will be familiar with this. It's called Ferber, F-R-B-R, standing for Functional Requirements for Bibliographic Records. And whilst Index has 3 layers, Ferber has 4. I've drawn it out so that the equivalencies are roughly aligned horizontally. In fact, Index and Ferber agree pretty much 100% on the nature of what is an item, an individual copy of a book. There's not much scope for disagreement there, to be honest. So they both start at that level. They, in fact, pretty much agree on what they both call manifestations. A product, in your terms, is a manifestation, and it's a manifestation both within the Index model and within the Ferber model. Where it all goes wrong, in a way, is at the top level of this. And you can see that in the library world, we have an extra level. What we call a work in the Index model is actually the very close equivalent, not exactly the same, but a very close equivalent of what in the Ferber, the library world, is called an expression. And above that, even more abstract, even more slippery as a concept, is the idea of a Ferber work. And the difference here can be highlighted by saying, I suppose, that in Ferber, that Swedish novel, Man som hatar kvinnor, and the English translation, Girl with the Dragon Tattoo, are 2 different expressions of the same work, whereas in Index, They are two different, albeit closely related works because one is derived from another. The key difference between index and Ferber is that those Ferber expressions are related to each other by their derivation from the same work. They are siblings, they're descended from a common parent work, whereas in index, they're related in a peer-to-peer fashion. They are peers of each other, related directly, rather than being related indirectly through a Ferber work. The seeming importance of work to librarians, I speculate this difference in viewpoint comes from the viewpoint that the relationships are more hierarchical, descending from works, rather than being directly related works, is actually because for publishers who generally use the index model in the way that they think, publishers have access to information about workflow. So this work is translated into that work, or it's abridged into a different work. Publishers' business is about those translations, those derivations, those abridgments. The workflow, the stuff that publishers do, is often about creating new works, one from another, whereas the library only has the end product to work with. They don't necessarily see the workflow. What they see is the end result of that workflow. So because they don't have access to information about how this index work is related to that index work, they see, right, here's two expressions, and they're both obviously derived from one kind of even higher level and more abstract work. This causes no end of problems. The difference between the meaning of the term work in the two models results in huge amounts of confusion when metadata people talk to each other. I mean, well, metadata people talking to each other is always dangerous. But when that's mixed in with confusions about terminology, it gets even worse. Sometimes it gets bad because people say the ISTC is a work identifier. But of course, for a librarian, the ISTC, which works at the work level on the right-hand side of the diagram, is actually an expression identifier for librarians on the left-hand side of the diagram. Now, once you understand that difference in terminology and you watch out for it when you're talking to librarians, it kind of all becomes clear. And you can begin to make links between the things that librarians talk about, the level at which they attach various different metadata elements, and you can begin to then say, right, that in Mark that librarian thinks of as a work title is actually this in Index or this in Onyx. There's been a significant amount of work done, and not by us, in mapping from one data representation to another here. Perhaps the best known, certainly the best documented, most easily accessible, is a set of mappings from Onyx to Mark. We saw Onyx and Mark earlier, by Carol Jean Godmy of OCLC. Let's go on, because I missed those. Right, so this is the paper I'm talking about. Carol Jean Godby's paper, which describes her work in taking Onyx data and translating it, mapping it into Mark. This sort of mapping enables OCLC and others to take publishers' metadata in one form, Onyx, and to use that as the basis for library metadata in another, in Mark. Of course, the Mark might require a little further enhancement, it might require a little checking, a quality assurance process, and so on. But the mapping gives you a real head start. A library usually has to wait for the book to turn up before it can create the library catalogue record, but they can get a head start if they start with the publisher's Onyx. Just as an aside, the mapping is largely one way. It's relatively straightforward to go from Onyx to Mark, but it's not at all straightforward to go the other way. Or rather, there isn't enough information, quite often, in the Mark record to create a decent Onyx record. Well, why not? Think about what Onyx is for. It's for book trading. Onyx doesn't exist in a vacuum. It's not there just because it seemed like a good idea. Onyx is there to solve a problem. It's about the book trade. It's not just a catalogue of books, but it's a catalogue of books with prices, with availabilities, with wholesaler and distribution arrangements. They're all there in the Onyx. And on the other hand, there's no need at all for those things to be in Mark. So if you take Mark data and you translate it into Onyx, what you have is an incomplete Onyx record. You've got all the bibliographic information there, but what you've not got is the whole point that Onyx exists. You haven't got that trading data. So mapping from Onyx to Mark, relatively straightforward because the bibliographic stuff is shared between both formats. But it's very difficult to go from Mark to Onyx because the key information that you want in the Onyx is simply not there in the Mark. But in her papers, Ms. Godby very clearly explains that the mapping from one metadata to another is to a large degree automatable. You can't always simply take a little fragment of Onyx and replace it with the relevant markup, but you mostly can do that. Sometimes there's a little bit more analysis work in there. There may be some logic. There may be some deduction necessary. But for simple parts of the record, the mapping itself is also very simple. You can take, for example, the contributor role XML tag that precedes the author's name in Onyx and just replace it with the terms $100E to turn it into Mark. I think I've got an example of that. So at the top here, we've got the Onyx record for one particular author. It's the author for this book. See, this book I left in there. And the key lines there, well, let's look at the contributor role, AO1. That simply means it's the author. And the name of the author, My Sherville. And at the bottom of the screen, we have the equivalent mark. 100, $1, Sherville, comma, my, $D, 1935, $E, author. Each of those individual little bits of data can be transferred directly from the Onyx at the top to the mark at the bottom, and you just change the syntax. The data itself is exactly comparable between the two. You've got the author's name, you've got, in this case, the date of her birth, you know that she is the author, you even know that she is the first named author. Because, of course, there's the sequence number in Onyx at the top, says number 1, and the mark is field 100. That means primary author. Any secondary or subsequent authors would go in field 700, I think. If only I'd put that in my notes. So this part of the process, replacing contributor role with $100E. So AO1 gets translated to the word author, and then the $E is added there. You're taking the same data and expressing it in a completely different syntax. They mean exactly the same thing, although they're going to be used probably in very different contexts. Now, it's unusual that the mapping is quite that simple and quite that direct. Most often, you need to take into account a little of the semantics of the data as well as the syntax. Why? Well, it's because metadata formats aren't neutral. They're designed by people with a job to do, people with opinions. And metadata formats end up having views and roles. Views and roles that are derived from the people who designed the metadata format. Mark is for libraries. Onyx is for the book trade because they were designed by librarians or book traders. There's stuff in Mark that's important only to librarians. There's stuff in Onyx that's important to the book supply chain. The interpretation of a particular piece of information in any one of the formats is dependent upon the domain, the role you want to use the information for. Essentially, it depends on whether you're a publisher or a librarian or a bookseller. Here's another example of what I mean. Further down that Mark record for this book, we've got the extent of the book. It's at the top, code 300 in Mark. The extent, the number of pages in the book, in this case, is 212. Whereas the Onyx record below tells you the number of pages is 245. Well, that's actually irrelevant. That's because it's two different editions of the same work. They were typeset differently. But if those two numbers were the same, these would mean exactly the same thing. If I'd been able to find the MARC record for exactly the same book, they would both have said the same number. The point I want to make here is that the Onyx record can say 245 pages, but it can also say 272. This is a novel. If you're reading it, the key figure is there's 245 pages to read. If you're in the production department and you ordered enough paper for 245 pages, I can see somebody smiling at this and nodding and thinking, yeah, I've done that. I've under-ordered my paper. If you're in the production department and you order enough paper for 245 pages, you've got about 30 pages short. You can't print that signature. Because, of course, what people mean by the extent of a book depends on which department they're in within the publisher. If you're in editorial, it might be 245. If you're in marketing, it might actually be 270 because they take into account in this particular book, by the way, look, isn't it great? There's some discussion material after the main body of the book. So you get a novel, and then there's a little discussion paper afterwards, a reading group guide. And the marketing people need to take that into account as well, because that's their bit of the book. And if you're in production, neither 245 nor 270 is the right number, because there's two blank pages as well. So you need to order enough paper for 272 pages. The word extent of a book is not just one number. It's highly contextual. It really depends on who you are and what you want to do with that number. In MARC, there really is pretty much only one number. There's a standard called ISBD, the International Standard Bibliographic Description, that MARC kind of bakes in, and it tells you that's what you look up, that's the number that you use. It even tells you the punctuation, like the X, the comma, the P, the full stop, and the colon, that you have to use. Those are all meaningful bits of information in MARC. I told you it was cryptic. So we've got two types of interoperability here. Remember that word, the I in index. One is about the syntax. Yes, you can probably take quite a lot of the Onyx syntax, the XML tags, the order they appear in, and translate it fairly mechanically into MARC, which has a different set of tags because it's not XML. They're very cryptic. They're mostly numbers and dollars and individual letters. But you can do automatic translation of that syntax. What you can't always do is the automatic translation of the semantics. In this case, the meanings of those different extents. 245 as an extent means something different to 272 as an extent. Which one you care about depends who you are. And there aren't any rules, really, about which one of those matches the one in MARC. You need to focus on the syntax for interoperability, but you also need to focus on the semantics for interoperability as well. I'll give you another example, one from within Onyx, publication date. It's a phrase, a term that we all use all the time, every day in our business. I get two sorts of queries about publication dates. First, what's the publication date of an ebook of Pride and Prejudice? Is it 2013 or is it 1813? People genuinely do ask that. Was that ebook published in the early 19th century? They don't ask it in those terms, but that's what they're really asking me. And second, publication date. If a book arrives at the bookshop a couple of days before the publication date, can it be sold, or does it have to wait till the publication date rolls around? Because the publication date is, of course, obviously the first date that somebody can buy a book. These are questions of detailed semantics. Are you talking about the first publication of the work in 1813, or are you talking about the publication date of the manifestation, the e-book product, in 2013? Is the publication date a nominal date, an approximate date? It's round about the time that the book is going to appear. Is it just a date that you put on the invoice for business purposes? Or is its definition the very first date that a customer can get hold of a copy of the book? If you think about those questions of semantics, librarians, publishers, booksellers will give you completely different answers. So if you're transforming data from one format to another, the syntax isn't the only thing that you need to worry about. The practical meaning of the data, the semantics, is vital. And a flexible format like Onyx, in the bottom half there, allows you also to be very precise about the semantics, because you can say this and this, whereas in a mark record you can't actually give two different sorts of extent. Here's some Onyx that makes it very clear that the e-book was published a year ago, even though the work on which it was published was first published 200 years ago. It also makes clear it's able, because it can repeat different types of publication date, it's also very clear from this little bit of Onyx that the print book on which, the print edition on which this e-book was directly based was published in 1985. And it also makes clear that there is a very strict sales embargo. So if it happens to turn up a couple of days early, you can't sell it. You have to sequester it, put it in the back room, keep it until the actual pub date rolls around. So a flexible format can also be semantically very precise. A pub date isn't just a pub date. It's a particular kind of pub date. And the formality and precision is what semantic interoperability is based upon. The linked data I spoke to you about last year. Linked data is an important aspect of the semantic web, and it relies for its value and the ability that you can link bits of linked data together. It relies on very precise semantics. And actually, that's in some degree the downfall of some of that linked data work, because people don't take enough care about those semantics. They end up linking people and public faces of people, or pseudonyms. And a pseudonym and a person are not the same thing. You would use different identifiers. It would be very annoying for an anonymous author to be outed because you've made inappropriate links through the semantic web. So you need to be very careful about the semantics of that sort of thing. It's my view that that semantic interoperability is much more important and much more problematic than the more obvious syntactic stuff. That was the linked data I showed you last year. So we've now seen 3 different syntaxes, 3 different formats for the same data. We've seen the mark, we've seen the Onyx, and now we see some RDF XML, some linked data. These all say pretty much the same thing. I wouldn't focus on the details of this. This isn't exactly the right way to do it, but it's enough to give you the idea that you can say exactly the same things in the RDF, in the mark, in the Onyx. 3 different syntaxes for the same, pretty much equivalent semantic data. 3. I really don't feel that's enough. Let me introduce a 4th. So this is called JSON, JavaScript Object Notation, where XML is a riot of pointy brackets. This is dominated by curly brackets. That's actually the main and most important difference. It's not really intended for human consumption. It's kind of like XML. It's text, but it's really text for computer consumption. You can read it in any text editing software you like. You could load it into a web browser. It might do something unexpected, but it is an effective way of communicating this data between 2 machines. JavaScript Object Notation, as its name implies, JSON it's usually called, was originally intended for use with the JavaScript programming languages, the language that you use to create web pages in a way. a language that works within your web browser. Put broadly, anything that you can click on a web page that isn't obviously just a link to another web page, anything that you can click on that does something within that page is almost certainly being powered by JavaScript. JSON's part and parcel of JavaScript. It's the way you define data within that programming language. It goes back to 2001, 2002 era, but it turns out that JSON's actually pretty useful outside of JavaScript too. It works with any sort of programming language as a data communication format. And thus, to some degree, it competes with XML. You can do the XML thing like that with Onyx at the bottom, or you can do the JavaScript thing like that with JSON. And you can convey much the same sort of data in much the same sort of way. The thing about JSON, though, is it's slightly shorter. Turns out that people think that's a really, really important thing. Well, let's look at some of the details of what we've got here. A contributor in JavaScript is a complex object, and so all objects in JavaScript get curly brackets, but contributors in Onyx can be repeated. You can have more than one of them. So in JavaScript, you have to have an array of them, a big list. So where it says contributor, the first thing it says after that is a square bracket. That introduces an array, a list of JavaScript objects. And then within that, we've only got, in this case, one contributor. I think the square bracket introduces the list, and then the curly brackets there and there, that is one contributor. There could be a second contributor below that, and then eventually you get to the end of the square bracket, the end of the list. JavaScript can also have text, it can have booleans, it can have numbers, but that's it. That's what JavaScript is. Within that contributor object, we've got all the familiar properties that we had before in the Onyx. We've got a sequence number at the top, number 1. We've got the first name and last name. We've got the contributor role. Wait, look. That contributor role is actually in square brackets, so it's an array. That's because in Onyx, a contributor can have multiple roles. You can be both the author and the illustrator. In this case, there's only one role, but it still has to be an array. It still has to be a list with one item in it. So you can build up your knowledge of JSON, and you can say, right, I can take my XML and I can transfer it directly into JSON without losing any real syntactic value. I can change, without losing any semantic value. I can change the syntax, but leave the semantics the same. This gives you a clear clue about the reason that you might want to use JSON, I suppose. We'll come back to it later. Like the Onyx XML, where you have a DTD and a schema, you can also have a JSON schema, which in principle at least could match one for one to the Onyx schema. However, let's flip back a bit. If you look closely, there are still differences. Where here we had, focus on the green bit, date format equals 05. What's that telling us? It's actually telling us in Onyx about the precision of the date. It says we only care about the year here. And that bit hasn't made it into the JSON yet. In order to put that into the JSON, we actually have to add a whole new property, this date format 05. You can do that in Onyx too, but the attribute, the green way of doing it, is preferred. And therein lies the rub. JSON looks very simple until you realize that every single Onyx data element can have something between 3 and 5 attributes. So nothing can be as simple as names before key my or sequence number 1. If you transferred the semantics of Onyx into the semantics of JSON, you have to allow for every single thing in the JSON to have a whole bunch of attributes or properties, not just a number, sequence number, but you have to say, this is sequence number 1, this is the person who told me, this is when they told me, because you can embed both that date and the source of the data inside the Onyx. Adding all those options into the JSON makes it incredibly complicated. It turns out it makes it exactly as complicated as the Onyx. So all that talk about JSON being simpler and smaller and maybe faster turns out to be a bit of a mirage, because once you make it do exactly the same thing as the Onyx, then it turns out to be exactly as complicated as the Onyx. So, let's go a little further. Here's another example, I suppose. Those attributes in Onyx, we had date format a moment ago. This is Datestamp. Datestamps, they're not actually that often used, but sometimes when you do use them, they are incredibly important. This one says product availability 21. That means the book is in stock. No, it doesn't, not quite. What this means is the book was in stock when this data was new, last week. Yes, it's ever so useful to know this data was in stock last week, but it's rather less useful than knowing it's in stock now. That Datestamp is really, really important. So you can't really do without all these little attributes. You have to put them in the JSON if you're going to use the JSON for the same sort of thing. So contributor role AO1 looks really simple, but that's very misleading. It needs to be that because you can have multiple contributor roles. And then it needs to be that because you can have all the attributes as well that say, who told you that the contributor role was AO1? When did they tell you? What type of organization were they? So the relative simplicity of JSON actually goes away once you make it do the same job as Onyx. Programmers get very, very excited about the difference between XML and JSON. They're actually very similar in some ways. They're both open, they're both free to use, they're both technologically neutral, they're both very highly interoperable, structured, relatively simple in most ways. They're both about communication rather than storage. They both use Unicode, all that sort of thing. If I were to put up a slide that said XML versus JSON, that would really flush out the zealots. And the zealots would say, my XML is better, it's more extensible. And the other zealots on the other side of the room would say, well, JSON is slightly smaller and more efficient. It works natively in a web browser. Well, yeah, it is slightly smaller and more efficient, but to be honest, if that's your prime concern, the best thing to do is zip all your data, because that will make it even smaller. So the smallness might be useful in some circumstances, but the bigger thing is that JSON works inside a web browser. You might use it in a web service, and that's pretty much the only reason why you choose one or the other. Just as data formats like Onyx and Mark and RDF might well be used in different circumstances, they're all for something, then these data syntaxes are also for something as well. JSON is often promoted as being the best way to do web services because of that smaller thing and because of the ability to work inside a web browser. But the differences between Onyx and JSON actually end up being very small. The most important thing is actually the semantic interoperability of the two. Whatever you do to the syntax, whether you convert it from XML or to XML RDF or to JSON, if you retain the semantic interoperability, if you don't change the definitions of the data, all of those conversions can be completely automatic. And you then have the choice of using whichever syntax, XML, RDF, JSON, is most appropriate for the job in hand. When you're designing your own systems, this is the lesson, I suppose, the definition you use for terms like work and product and publication date need to exactly match those used by your peers in the rest of the industry. Because only by standardizing on the meanings of the data can you interchange your data with other people in the business. That semantic focus, rather than focusing on the exact syntax, is the key to where we need to go next. Thank you very much.